Good day, everyone. I am Moricid Maliga, third-year Bachelor of Science in Civil Engineering student of University of Southern Mindanao. Today, we are going to talk about the moment distribution method. So this is a subject requirement for our reporting, for our subject course, structural theory. This is for the third reporting. So what's the problem? So for our problem, we are going to use either the Hardy-Cross method or the moment distribution method. But in this problem, we are going to talk about, or we are going to use the moment distribution method. So this is our problem. So as instructed in our problem, first, we have to draw the shear and moment diagram of the frame shown in the figure. So ito yung figure natin. Ito siya. So use the Hardy-Cross method or the moment distribution method. So ang gagamitin natin is the moment distribution method. Second, after solving the values for the shear and moment diagram, ang gagawin natin is co-compare natin ang answer natin using approximate analysis. So, ayun siya, makikita natin dito, may mga point, joint A, joint C, joint E, joint F, joint D, and joint B. We have the length of from point B to D is 15 feet. From point D to F, meron tayong 15 feet. And from point A, point B, point C to point D, point E to point F, it is equal 30 feet. It is equal to 30 feet. And meron tayong applied force or ang load natin at joint E na 9 kips, and also in our joint C is 18 kips. So our E here is constant. So this is our actual frame. So it's the same as the figure shown in our in the problem in the previous page. So eto siya. So yung figure na pinresent or yung figure na binigay sa atin in our problem, eto na yung kalalabasan niya. So kapag hinati natin ito siya into two figure, ito siya, yung kalalabasan or kapag in-apply natin yung force doon sa figure na yon, meron tayong 9 kips and 18 kips, di ba? Magbe-bend siya dito ng pagganyan, paslant. So hinati natin yun siya. So yung first figure natin is magbe-bend siya ng ganito. So that is frame subjected to MQ1 moments. So plus frame subjected to MQ sub 2 moments, ito siya. So dito lang siya magbe-bend. Yan siya dyan na part. So kapag ito siya, itong dalawang ito, ito yun siya, same as this lang. Hiniwalay lang natin siya kasi dalawa yung force natin. So ipinakita natin if yung isa-isa nating each force natin, paano siya paano yung ating figure magre-react doon sa force na ina-apply natin. So ayan. So for now, let's solve the member stiffness factor in which when the modulus of elasticity for all the members of a structure is the same, it is usually convenient to work with the relative bending stiffness of members in the analysis. The relative bending stiffness, K, of a member is obtained by dividing its bending stiffness, K, by 4E. Thus, relative bending stiffness of the beam of this problem is given by K is equal to K over 4E. So, which is also equal to I over L, or inertia over the length. So, if you're going to solve yung ating stiffness factor ng ating members, so since as we can see in our figure, dun sa figure natin, equal lang yung ating member A, C, B, D, C, E, and D, F, in which uh, magiging same lang din yung kanilang stiffness factor. So we are going to use the formula I over L is equal to I over 15. Also, same din yung stiffness factor ng ating members CD and EF, which is equal to 2I over L, which is uh, 2I over 15 is it is also equal to I over 15. Next, what are we going to solve now is yung distribution factors of each members doon sa figure natin. So, the formula for determining our distribution factor is the stiffness factor all over the summation of this stiffness factor. So for our, since equal lang ating AC at BD, so same lang yan siya ng value, and since it is fixed na siya na force, ibig sabihin ang distribution factor natin doon is 0. So ayan, ito 0. Next, for our member CE, it is also equal sa member EF, as if we are going to look back in our figure, same lang yan siya, silang dalawa. So in our formula, K over summation of K, or the stiffness factor. So 1 over 15 all over 1 over 15 plus 1 over 15 is equal to 15 over 30, in which ang distribution factor ng member CE natin at EF is equal to 1/2 or 0.5. For the next members, which is also these three members is also equal then yung kanilang distribution factors, as we can see in our figure, kasi since it is symmetrical, the figure is symmetrical. So distribution factor of CA is equal to distribution of factor of CD and CE, in which is equal to I over 15 all over I over 15 plus I over 15 plus I over 15, which is equal to 15 over 45, or in simplest term, it is 1 over 3. So next, what are we going to look naman is our fixed end method. So in looking for our fixed end method, what are we going to do is to let 6EI delta prime sub 1 is all over 15 squared, in which we are going to assume it into 100 kips feet. So as we can see in our figure, so the fix, since the figure is symmetrical, ang ating fixed end method of AC is equal to CA. So since yung force natin dito is, let's assume that if to the right it is positive and if it is to the left it is negative. So, since our force is nagbend siya to the right, it is positive 100. Same as dito sa BD natin and DB. Since it is to the right, it is positive 100. So, since dito na siya, yung point D to E natin, or point C to E pala, is to the left na siya, negative 100 ang ating fixed end method. Same as from point D to F, since from here, nagbend siya to the left, it is negative 100. So, for our MQ2 or MQB, um, same, let's assume that if nagbend yung ating figure to the left, it is negative and positive if to the right. So, since yung ating figure is nagbend siya to the right, it is all positive. Lahat siya positive. So, the fixed end method of point C, E, and point EC is equal to positive 100. And also, point DF and point FD, it is equal. So, it is positive 100. So, that are the values that we are going to use in order to solve for the moments, ano ba yung tawag doon? Uh, moments ng figure natin. So, eto. So, in our table, using the values na nakuha natin yung values ng yung distribution factors ng ating each members, nakuha na natin. And also, nakuha na rin natin ang fixed end method ng ating each members. So, previously, if you are going to look back sa ating na-solve kanina, ang fixed end method ng ating excuse me, ang fixed end method ng ating point AC is 100, positive 100. Point CA, it is 100. Point C, since wala yung point CD natin, it is 0. So, negative 100 sa point CE, EC, negative 100, 0 for EF and FE, FD and DF is negative 100, DC 0, so let's leave it blank, and for DB and BD, it is positive 100. And also, as we can see, the value of our distribution factor is na-determine na natin kanina. So, since yung point AC natin and BD is located sa fixed force na area natin, 0 yung distribution factor natin doon. So for our joint C, we have 1/3 or 0.33. For joint E, the same as joint F, it is 1/2 or 0.5. And for our joint D, it is 1/3 or 0.33. So now, let's look for the members or let's look for kung paano natin nakuha yung mga values na nandito sa table natin in order to determine the moments ng ating figure. So, like for example, here, lahat ng mga blanks natin dyan is 0 na siya. That is equivalent to 0 na. So, dito. So, yung balance natin dito, negative 100. Paano nakuha natin yung 50 is nag-multiply tayo ng yung negative 100 natin is minultiply natin ng distribution factor natin which is 1/2. And Kapag balance ang hinahanap natin, hahanapin natin is yung halimbawa kapag naging negative yung pag-solve natin, gagawin natin siyang positive. So here, negative 100 times 1 half is negative 50. But since we are looking for the balance, ang natin dyan is 50. So here, I forgot to change it kanina or um, nagkamali ako. So dito is since negative 100 times 1 half, it is positive 50 yan siya dito. So, yung dito, paano natin siya nakuha? Yung 25 at saka 0. So, ito, multiply lang natin. Ito, 0 yan siya, di ba dyan? So, 0 multiplied by 1/3 or divided by 3, it is equal to 0. So, yung 50 naman natin dito is 50 multiplied by 1 half is 25. So, dito naman, nagtataka kayo, paano naman natin nakuha yung ating balance sa ating second case or for our case 2. So, ang gagawin lang natin is to look for the total of the case over moment of every joints. For example, uh, here in our case joint A, so we have 0 dito. So, automatically, it would be 0. So, joint C, ang total sa joint C naman natin, we have 25. So, 25, imumultiply natin siya sa 1/3. And since balance ang hinahanap natin, gagawin natin siyang negative. So, it would be negative 8.3. So, the same as in joint E, yung 25 natin dito is gagawin natin or multiply natin siya sa 1 half. So, magiging negative 12.5. So, ayan siya. So, the same process for our joint F, the same process for our joint B, and also for our joint B. So, ngayon, ang gagawin naman natin, nakikita natin yung arrow dito. So, ang gagawin na natin is multiply natin yung 0 sa ating distribution factor in order to balance natin siya. So, halimbawa, negative 8.3 divided by 2, negative 4.2. So, all of this process is done repeatedly hanggang sa makuha mo or you have to set a limit kasi in order to para malaman mo kung hanggang saan case ka lang titigil. So if halimbawa here nagset tayo na hanggang 0.1 lang tayo mag-stop. So as you can see here 0.1 lang yung 0.1 lang siya, hindi kasi if mag-proceed pa tayo sa case 8, it's either maging 0.08 or 0.09 na yan siya. And so, ayan. That would be the result. So, after solving it or tabulating it, yung determining the values in our table, ang kukunin natin is the summation of these values of each member. So for our member AC, we have 97.304 for the member or for moment QA. So we have for CA, meron tayong 94.19, for CD, negative 8.86, for CE, negative 85.3, for EC, 61.73, 61.73 also for EF, negative 61.73 for FE, negative 61.73 for FD, 85, negative 85.3 for DF, negative 8.86 for DC, 94.19 for DB, and 97.04 uh, BD. So, as we can see, napapansin natin that sabi nga natin kanina, the figure is symmetrical. So, as we can see, yung values natin is nagiging symmetrical din siya. Ayan. So, after getting all of the values doon sa ating table, so what are we going to look for now is the reactions. Uh, uh, reactions in every point natin. So, in our point CD, in our point CE pala, so using the help of the values na nakuha natin doon sa ating table, we can determine that the reaction in this point is the summation of moment E is equal to 0. So let's assume that counterclockwise is positive and clockwise is negative. So to solve it, yan, Cx is times 15 minus 85.3 minus 61.73 is equal to 0. So, um, uh, ayan na siya. So, if you're going to calculate that, transpose natin yung values, ang Cx natin, madetermine natin as 91.8 kips to the right. That means it is positive. So, also, since Cx is all equal to dx, so we have also 9.8 kips to the right also. So next for our point AC, so or BD, the same. It's the same. What we're going to do is let's assume counter clockwise positive. Let's use the summation of moment C at point C is equal to 0. So A sub x times 15 plus 97.04 plus 94.19 is equal to 0. AX, if you're going to transpose it all, if substitute natin yung value, or i-transpose natin and divide both side by 15, makukuha natin yung value ng AX is 12.79 or 75 kips to the left. Also, since it is equal to BX, it is also 12.75 kips to the left. So, next is yung atin dito, for our Q21, so it is equal to 19.6. So, through assuming that to the right is positive, we are going to use the formula of summation of horizontal forces, which is equal to 0. So, Q sub A1 is plus 9.8 plus 9.8 is equal to 0. So, our reaction here is 19.6. Ayun na siya. 19.6 to the left. Dito naman is ang ating hahanapin is ang QA2 in which ang gagamitin natin is the same, the summation of horizontal forces which is equal to 0. So Q A sub A2 is equal to 19 points is minus 19.6 minus 12.75 minus yan dito guys ha, minus 12.75 is equal to 0. Therefore, Q sub A2 is equal to 45.1 kips to the right. Ayan. So, next, for our second figure, for our moment QB. So, ito na yung table natin. So, the same as the how I have explained kung paano natin yung nakukuha yung values natin doon sa ating table in our moment QB, uh, QA rather. So, ganun din natin nakukuha yung ating values dito sa ating second table. So, since na-solve din natin kanina na only the member CE, EC, FD, and DF are the only members na merong fixed end method. So, ayan siya. So, since it is all positive. So, the same as how I have explained yung table kanina, ganun pa rin natin kukunin yung values dito sa table natin in order for it to balance. So, after you get all of the values, i-add mo lang yung lahat ng values dito for the moment QB of each member. So we have here values 11, negative 11.8, negative 23.5, negative 35.3, negative 58.81, 52.95, negative 52.95, negative 52.95, 52.95, 58.81, negative 35.3, 23.5, negative 11.8 for the summation of MQB of each member. So, ito yung each members natin. So, now, the same as for the table 1, we are going to look also for the reactions of its figure. So as we can see here from the reactions in point CE, DF, it is equal kasi it's symmetrical. So if what you're going to use here is the formula of summation of moment E. It is equal to 0. So if we're going to use that, ang makukuha natin is 7.45 keeps to the left, dx 7.45 keeps to the left. So also from point dito is ang gagamitin natin is summation of moment C is equal to 0. So if you're going to use it, AX times 15 minus 11.8 minus 23.5 is equal to 0. If you're going to transpose it, divide both side by 15. AX would be equal to 2.35 kips to the right, and BX is also 2.35 kips to the left. Next, is for our Q sub 22. So what are we going to use is the summation of forces in summation of horizontal forces also. So if you're going to use that, ang makukuha natin is Q, this is QB1 is equal to 14.9. QB1 pala yan siya dito, guys. QB1. So, also, here, next figure, QB2 natin ang hahanapin natin, in which, ang gagamitin natin is summation of forces, horizontal forces. So, summation of horizontal forces is equal to 0. If you are going to use that formula, or that equation rather, so ang makukuha natin, Q sub B2 is equal to 19.6 kips to the left. So by superimposing the horizontal forces at joints, C and E, we obtain, so ito yung ma-obtain natin. So using the horizontal forces na horizontal forces natin sa joint C at E. So, meron tayo dito, using this horizontal forces, naka-obtain tayo ng dalawang formula in order to get the C sub 1 and C sub 2. So, meron tayong 45.1 C sub 1 minus 19.6 C sub 2 is equal to 19. And we have negative 19.6 C sub 1 plus 14.9 C sub 2 is equal to 9. So, para makuha natin siya, i-equate natin yung dalawang formula. Ayan siya, C2 is equal to 45.1 C sub 1 minus 18 all over 19.6. 9 also 9 plus 19.6 C sub 1 all over 14.9. So if we are going to equate it, since C2 is equal to C2, so this is both equal. So kapag kukunin natin yan siya, eto, ang makukuha natin, 19.6, ayan siya, cross multiply lang natin, ayan, and of course, combine like terms, and transpose, and makukuha natin that C1 is equal to 1.5.447. So, since nakuha na natin yung C1, pwede na natin gamitin any of these two equation para ma-determine natin yung value ng C2 natin. So, if you're going to substitute the C sub 1 here, ang makukuha natin is 2.636. So, the same as here. So, kapag gagamitin natin ng C1 dito, ang lalabas is 2.636 pa rin. Yan. Next. So, ayan na siya. So, ito, pinagsama natin yung summation of moments Q sub A natin in every members. So, pinagsama natin para makuha natin yung member end moments in actual frame. So, para ma-determine natin yung member end moments, ang gagamitin natin na formula is C sub 1 times moment Q sub A plus C2 times moment Q sub B. So, for our MAC, gagamitin lang natin yung formula na ito. So, 1.545 times 97.04 plus 2636 times negative 11.8 is equal to 118.82 kips fit. So, the same as yung for our members A, C, B, C, E, C, E, F, F, E, F, D, D, F, D, C, D, B, and B, D, ganun pa rin yung gagamitin natin. So, since to make the process easier, since equal lang yung hahanapin natin yung parehong equal lang yung kanilang member and moments. So, we have equal yung ACBD, CADB, CDDC, CEDF, ECFD, EFFE. Those are equal. So, if we are going to use this formula and substitute these values and yung C2 and C1 natin, which is 1.545 and 2.636, makukuha natin that moment at CA and DB is 83.45 kips feet. For CD and DC is negative 106.88 kips feet. For CE and DF, we have 23.5 kips feet. And EC and FD, we have 44.44 kips feet. And for our EF and FE, we have a moment of negative 44.45 kips feet. So, for the actual moment distribution natin. So, yung moment distribution natin, ito na yun siya, yung moment distribution method natin. So, ayan. Ito na yun siya. For our actual reaction, for our horizontal A and horizontal B, or HA or HB, we have 13.448 kips to the left, and also HC is equal to HD, which is 4.53 kips to the left. Also, for our FY, we have 2.96 upward. EY, we have 2.96 downward. For DY, we have 7.13 kips upward. CY, 7.13 kips downward. So, for solving for reaction, ito lang yung gagamitin natin. So, HA, we have negative MCA plus MAC all over length. If you're going to substitute it, 83.45 plus 118.82, negative din siya, all over 15. Makukuha natin is 13.48 kips to the left. Also, HE is equal to negative MEC plus MCE all over L. So, ayun siya. Makukuha natin is 4.53 kips to the left. The same as here. So, para makuha natin yung Fy natin and dy natin, gagamitin natin yung mga formula or yung summation ng moments natin in specific joints. So, here, ginamit natin is summation of moment of E. So, we have the value of Fy in 2.96 kips upward. And dito, moment of movement at C, we have dy of 7.13 kips upward. And here, ginamit natin is sa moment, summation of horizontal forces, which is 2.96 kips downward ang ating EY. So, dito naman is, meron tayong C, ginamit natin is also summation of horizontal forces, in which ang CY natin is 7.13 kips downwards. So, ayan siya. After solving all those reactions, eto na yan siya yung ating na-draw na shear diagram and bending diagram. So, all of the values or na sinolve natin, eto na yung siya ang result niya into as diagram. So, portal method. So, ang portal method natin, ito yun siya. Ito naka-shear pa ito siya. So, this means that these values, ito yun siya yung mga nagre-resist sa ating loads in order to masustain natin yung stiffness ng isang figure or nating structure. So, ito yun siya. So, dito naman natin, makikita natin that dinivide natin siya. Or meron, anong ba ang tawag dyan is, parang nag-create tayo ng sections. Ito yung sinasabi natin na yung mga internal forces natin. Ito na yun siya. Kapag hinati natin yung dito yung structure, ito yung magkakaroon tayo ng mga internal forces. So, kapag hindi natin na hinati, of course, it's given that wala rin tayong internal forces. So, that is for the portal method. So, all of these values is also solved using different formulas and different methods, and ito yung nakuha natin na values for this portal method. So next, what are we going to do is to compare our answer using approximate analysis. So this is for the figures or the diagrams for our shear force. As we so for in our sa green, yung naka-green na pen is yan yung ating moment. Yung shear force diagram natin using our moment distribution method. And yung sa right side natin, yung color orange, ito yun siya yung yung sa portal method naman. So as we can see, all of this is the same naman siya. So the kwan lang is medyo nagkaiba lang. So ito, 13.5, 13.48, it's still the same. It's just maybe moment distribution method is more specific siya. So if you are going to round off, so it is the same as 13.5. So the same values here, it is also equal here. Ayan siya, 4.58, 4.5. Ayan siya. Also, for our bending moment diagram, so here in the green or in the left side natin na diagram, that is the moment distribution method natin na bending moment. So to the sa right naman is that is the portal method. So also the same lang yan siya. It's just that we use different methods. So they have the same results and ayun siya. It's just that ayan, it's just that um dito is it is fixed according to what I have read or what I have watched in YouTube. Dito is fixed na yun siya. So we have three forces: the horizontal, vertical, and a moment. So far that is what I have noticed for the difference of the moment distribution method and portal method. So, and we're done for today. So, thank you very much for watching. So, um, I am Morsid Maliga, again, a Bachelor of Science in Civil Engineering student of University of Southern Mindanao. So, I am very thankful. So, I am very thankful of you for listening and watching. I hope you learned something. And if you have noticed anything wrong, please feel free to correct me, as I am still a student and I need to. I have so much. I have so many things to improve. So I will accept it constructively. And yes, thank you very much for watching.